Hey, hi. In our last session, we were discussing about what is a NAT and different types of NAT, that is static NAT, dynamic NAT, and port address translation. And we discussed about like what is a double NAT, what is dual NAT, and we discussed about what is source NAT and what is destination NAT, what is U-turn NAT, and what is identity NAT as well. Okay. Now in this session, we'll discuss about like what is broadcast domain, what is collision domain, all these things. Okay. So let's start. Broadcast domain is nothing but like if you have n number of devices. Okay. If they want to communicate with each other by using the broadcast messages is called broadcast domain. Okay, suppose like these are the list of devices we have in the network. Okay, so if they want to communicate with each other by using the broadcast messages only, if one want to communicate to some other, but they have to communicate with broadcast messages only, there is no like direct to direct communication. Okay, so that domain is called broadcast domain. And we have
Okay.
collision domain. So collision domain is nothing but it happens like in case of hubs, bridges, repeaters, all these things. So collision domain is nothing but is a network segment where two or more devices sharing the same bandwidth or same path. Okay, so that is called collision domain. So let's discuss in detail about collision domain and broadcast domain by using these diagrams. Okay, so we are discussing about broadcast domain, right? So here if you can
Yeah.
see broadcast domain is nothing but this is a switch. Okay, so here what's happening, they are sending to all the other computers, right? It is coming to switch and it is going back to the other device. Okay, so like if you can say this router is there, no, from this router. Okay, this part is called broadcast domain. Okay, and so if you can see collision domain, so hub, right? So like if they want to communicate with each other, it is passing to all the mediums, right? So that is called collision domain. Okay, so here if you observe for hub, how many ports it is consist of. Okay, so that doesn't matter, everything is called as one collision domain. Okay,
Okay.
suppose like this is the switch. Okay, so here whatever the each port connected to the switch, for switch each port is called one collision domain. Okay, for switch each,
Okay.
this is a switch each port is called one collision domain. Okay, so suppose here we have one device connected and here also one device connected, and here also like other device connected, but this hub, but these all devices are connected to this hub, right? So
Yeah.
what happened, like for hub, how many number of computers is connected doesn't matter, but everything whatever is connected to a hub, everything comes under one collision domain. Okay, but in case of switch, whatever the devices is connected to each port, that belongs to like other collision domains. Okay, is it clear about collision domain? So here like collision domain, what we are discussing, like it's using the same path, right? If you can say two or more devices sharing the same bandwidth or path. So if they want to like communicate with this router or something, they're using the same path, that is switch. Okay, so here what's happening, switch each port, it is called one collision domain. Okay, so here switch like it is connected to some other computers and some other network devices. Okay, so here what's happening, so collision domain it's happening with respect to hub, all the ports is one collision domain, and switch like these are into some other collision domains. Okay, and when it comes to
Okay.
broadcast domain, okay, so this is called broadcast domain. So what we are discussing here, broadcast domain is nothing but where they can hear from the broadcast. Okay, so that is called like broadcast domain. Okay, is it clear about broadcast domain and collision domain?
Yeah. Yes.
So if you observe here, okay, this is also one switch and this is also one switch. Okay, so here
Yeah.
for each port we have one different collision domains. This one, two,
Yes.
3, 4, 5. Okay, but everything like which are connected to this router, it is having one broadcast domain. Okay, so what we can say, for switch each port is one collision domain, and for router one broadcast domain for each port.
Okay.
Okay, Okay, but however, like we have three devices. Okay, hub. Okay, all ports connected devices are belongs to one collision domain. Okay,
Domain.
suppose we have switch. For switch, how many collision domains we have? For each port consists of one collision domain,
Okay.
and everything comes under one broadcast domain.
Broadcast domain.
That is about collision domain and broadcast domain. Okay, and we have like hub and switches, right? So let's discuss about what are the differences between hub and switch. Okay, hub is a physical layer device, and in case of switch, it's a data link layer device. Okay,
Okay.
and it has no intelligence. It means that no intelligence is nothing but like every time it is transferring the traffic to all the other computers which are connected to it. That mean to say it has no intelligence. But in case of switch, it's an intelligence device. So depends on the MAC address or ARP table, it will send or receive the information, right?
Yeah.
Okay, so here we have like I mean hub is nothing but it works on zeros and ones, but in case of switch, it works on the physical addresses. Okay,
Yeah.
so hub it was always to broadcast messages for everything whatever is connected to it. Okay, but in case of switch, it does broadcast and unicast traffic also. We'll discuss about what is broadcast, what is unicast traffic, all these things. But hub does only broadcast, but in case of switch, for the first time it sends a broadcast message. But after that, once it is having the ARP table information, then it will send one-to-one communication, right? That is called unicast. Okay, and it has like hub has one broadcast domain, and switch also has one broadcast domain. Okay, but here if you can see, hub consists of one collision domain and one broadcast domain. Okay, but whereas in case of switch, one broadcast domain and collision domain depends on the number of ports.
Okay.
Okay, so here what we are mentioning for in case of hub, whatever the devices is connected to it, everything belongs to one collision domain. It consists of one
Domain.
broadcast domain. Okay, so here what's happening? Switch one broadcast domain only it is connected to, but number of collision domains it depends on the number of ports which consist of.
Okay.
So that is about differences between hub and switch. Okay, so we were discussing, right? Like what hub is doing. Hub always send the broadcast messages. Okay, but in
Yeah.
case of switch, what it does first time broadcast messages, and when it has ARP table information, then it does unicast messages, right? So let's discuss about what is
Yeah.
unicast, what is multicast, and what is broadcast traffics. Okay, so unicast communication is nothing but one device in like on the network to another device on the network. Okay, so it means to say in a simple way, one-to-one communication is called unicast traffic. Okay, and
Okay.
suppose like let's me try with some example here. This is a network and this is another network. Okay, so here we have many computers. Here also many computers are there. Okay, so this one-to-one communication is called unicast. Okay,
Okay.
okay, and multicast is nothing but one to many. Okay, one to many, but not all. Okay, one to many, but not to all computers. Okay, so here we have like one to many it is computer connecting, right? But not to all the computers. Okay, so that
Yeah.
is called multicast traffic. Okay, and broadcast is nothing but one to all. Okay, so it means to all this device, this device, this device, this, and this. Okay, is it clear?
Yes.
Unicast is nothing but one-to-one communication. Suppose like let me tell you like like in a simple way for you to understand. Okay, suppose we have some computers here. Okay, so here also like there are many computers here in network E. Okay, so unicast is nothing but one to one.
One.
Okay, so this is unicast.
Okay.
Multicast one to many, right? So one to
Yeah,
either it
but
could be
not all.
this one, but not all. Okay, this is multicast. Okay, and broadcast is one to all means this one to this, to this, and to this network, and to this also. Is it clear? This is called
Yeah.
broadcast. This is about broadcast traffic, we can say. Okay. So like in case of hub, every time it sends to all the ports, right? That is hub. Always broadcast. In case of switch, for the first time it is broadcast, and for the second time it is unicast.
Test.
That is about like unicast, multicast, and broadcast traffic. And we have like one more type of communication that is called simplex communication, half duplex and full duplex. Okay, so simplex is nothing but it's unidirectional traffic
Only
only. So one to another, it is unidirectional. Okay, half, suppose consider that it is source and destination, source, destination. Okay, so simplex communication is it's a unidirectional communication. It's like it from one to another communication, like it's a unidirection.
yeah.
Okay, and half duplex is nothing but both device can send their information. Okay, suppose A is another device, B is some device. Okay, so here in case of simplex, suppose let me mention A only. Okay, A, B. Continuously A will send information, B will receive the traffic. Okay, but in
Yeah.
case of it won't send traffic back to A. Okay, that is called simplex.
Yeah.
But in case of half duplex, A and both can share the data, but only one at a time. Okay,
Okay.
so here A is sending information, B is receiving. At the same point of
Yeah.
time, B can't send information to A. Okay, after its completion, then B can send information
Completion.
and A can receive. So only one at a time. So you mean to say here only one direction flow. Okay, so here both directions are there, but
But once it.
once at a time. That is called half duplex communication. Okay, full duplex, both directions is there, but at same time.
Okay.
That is called like a simplex, half duplex, and full duplex communications. Is it clear?
Yes.
Okay, so let's discuss about VLAN topic. So VLAN port channel ARP. Okay, so what is VLAN? So VLAN is nothing but it stands for a virtual local area network. Okay,
Okay.
so like VLAN is a customized network where we can create one or more local area networks. Okay, suppose we have one LAN, it is okay, one physical LAN. This is one physical LAN, and here also we have one physical LAN. Okay, so what happens? Suppose here we have HR team is there. Okay, so here also HR team is there. Okay, but they need to have both same access, right? So what they will do?
Yeah.
We will this is one physical LAN, this is one physical LAN, right? So what they will do? This HR subnets whatever they require, they keep in one logical LAN. Okay, so that's
Okay.
what VLAN is a customized network which create from one or more local area networks. Okay, so that is called VLAN. Okay, so here it enables a group of devices available in multiple networks, group of devices to combine into a logical network. You got it? These are two physical networks, and we are combining them
Yeah.
into one logical network. It's called VLAN.
Okay.
So the result will become a virtual LAN that is administrative like so. Whatever the administration purpose, like access we need to provide for this VLAN, will provide that. So HR team they need to have some social media access, Naukri access, everything, right? So depends on their
Yeah.
or I can say day-to-day jobs. They need to have access, right? So this is one physical LAN. This is some in Bangalore. This is in Hyderabad, but they need to have same access. Okay. So at the
Mm.
point of time, we will keep those kind of like networks into one virtual network that is called VLAN. Okay, so it's a called logical network also. So based on the logical network, we'll provide the access to the virtual network. Okay, so
Okay.
this VLANs are identified by number. Okay, so VLAN 1, VLAN 2, something like that. Okay, so we have the
Okay.
VLAN range starting from 1 to 4094. Okay, so on a VLAN
Okay.
switch, okay, like you can then like so why we are doing VLAN virtual network? Because we can improve the performance, right? Because we are keeping like whatever the same kind of access required in two different locations in one logical network. Okay, so by that it improves the performance. Okay, and tightening security is nothing but like no one can be able to access the HR team, something like that. Okay,
Okay.
and ease of administration, this is the main point. Okay, so it's easy to administrate. HR team, they need to have one access, though they are sitting in two different locations, either in within the India or out of the state, out of the country also. But they'll be having same kind of access or privileges. Okay,
Okay.
suppose users are there, users who is there in Bangalore, who is there in Hyderabad, they need to have same kind of access. So what we will do, we'll put them in one VLAN and we will try to provide you access to that VLANs. Okay,
Okay.
that is called like ease of administration. Okay, so in the VLAN, like we having two kind of protocols, that is VLAN trunking protocol and spanning tree protocol that are used in the switches. Switching concept will
Okay.
be there, right? So in case of switching, we
Yeah.
have a virtual like VLAN trunking protocol and spanning tree protocol will be there. So we'll discuss about like later on classes. Okay, so this is
Okay.
not, so to be frank, this is not my expertise, like I didn't work on this, but in theoretical wise we'll discuss on that later on. Okay, but in
Okay.
switch we have VTP and STP. VTP is nothing but what VLAN trunking protocol.
Virtual.
SPT is nothing but spanning tree protocol. This is about VLAN. Okay, so like so what we are doing here, if you can see, this is one router R1, switch 1 is there and switch 2 is there. Okay, suppose here like we have the manufacturing team which is connected to this switch, and sales team is there, HR team is there, and sales team is there. Okay, so here if you can see, manufacturing team we given as VLAN 1. Okay, VLAN 1, and for sales team, like this, let's do VLAN HR team we given VLAN 3, and sales team they are connected to two switches, but we are giving the same VLAN ID to them. Is it clear?
Yes.
So that is the like a purpose of VLAN. Okay, so they are, though here they are sitting into different locations, right, to different networks, but we are mapping with same VLAN with respect to sales here. Okay,
Okay.
and so we have the VLAN ranges, right? 40 to 4095 is the ranges, and like it can be you. So here like I think this is something I need to modify it. Okay, so VLAN 1 is a default VLAN on the switches. You cannot delete or add this VLAN. Okay, and VLAN numbers from 2 to 1001. Okay, so it's normal VLAN. We can edit these VLANs and we can like use it wherever we require. And if we don't want, we can remove this also. Okay,
Okay.
so this is some other functionalities. Okay, we have VLAN 1002 to 1005. It's related to some Cisco, and these are some other numbers. If you are exceeding with VLAN 2, VLAN number 2 to 1001, then they will go with this extended range 1006 to 4094. Okay, so here 0 to
Okay.
4095 is the range of VLAN numbers. Okay, VLAN number 1 is it's a default VLAN and we can't modify it or delete it. Okay, we can edit it, but we can't delete it actually. Okay,
Okay.
editing is possible with this one, but we can't delete it. But so usually if you can any VLAN is there in the organization, they will start from 202 1001. Okay, if they are like occupied, then they will go with 1006 to 4094. This is about
Okay.
VLAN ranges. Okay, so we discussed about
Okay.
VLAN and VLAN ranges. Okay, next one more thing concept is called port channel. So here like let me tell you if two switches are there. Okay, so what we can say, like it is standalone. Okay, so if these two switches are there, so like port channel is a communication link between two switches supported by matching channel group on the interfaces of the switch. Okay, so let me tell you an example. Suppose we have switch 1, this switch 1 is there, suppose it's connected to some other switch, switch 1,
Okay.
switch 2. So if these two switches are connected with each other by using only one link, okay, so what happens, some issue happened to this link, we need to have some other link to be available, right? Suppose this is some 2 Mbps link we connected, between 2 Mbps link we connected between the switches and switches. Okay, so for some reason there is a failure of this cable, so some issue is there on the ports and it is down. Okay, so we need to have some backup, right? So for that purpose,
Yeah.
what they will do, they will connect two cables between the switches, that is called port channel. Okay, so this is, so 2 Mbps, this is some 1 Mbps. Okay, so what happens, they will share the load on the two links. So one, though, if issue, if any issue happen to one, then there is another to take care of it, right?
Okay.
That is called port channel. Okay, so if you can, port channel is also referred to a link aggregation. That is fine. Okay, port channel combine the bandwidth of multiple Ethernet ports into a single logical link. So physically, it is two links. One link between switch 1 and switch 2. We connected two links, link 1 and link 2. Okay, so logically, this one link and they will share the load.
Okay.
So here, link 1 is there and link 2 is there. Okay, so here between switch 1 and switch 2, we connected two links. One link 1.5 Mbps and another link 1.5 Mbps. So in total, 3 Mbps, right? In logical. So physically, for each cable is supporting 1.5 Mbps, but logically, between the switches, we have 3 Mbps connectivity. So it provides, like what I can say, it's kind of backup, we can say. So if it's failure, then we have something to take care of it. Got my point?
Okay.
So like if you keep, like a normal standalone process, if you have only one it will be there. Okay. And another, it won't be available. So it will be standby, but we have to, trigger the traffic and move the traffic to here. But in case of use port channel, two links will be available. Both can share the bandwidth, I can say. That is what it is. Okay. And port channel is also called as link aggregation group. Okay.
Okay.
That is about port channel. And we have, ARP, we discussed it, no? ARP stands for address resolution protocol, right? So we have different types of ARP available. Let's discuss about those things. Okay. So ARP stands for address resolution protocol. It converts IP address into MAC address. Okay. So inverse ARP is nothing but it's inverse ARP, like reversing to ARP, in inverse of the ARP. Okay. It is used to find out the IP address by using the MAC address. Okay. It means to say MAC address to IP address is called inverse ARP. Okay. Is it clear? Hello? Hello?
Hello.
Can you hear me?
Yes.
Yeah. So ARP is nothing but IP to MAC address. Okay. So inverse ARP is nothing but MAC address to IP address. Okay. And we have one more ARP called as reverse ARP. Okay. So reverse ARP is nothing but, used by a host in a LAN to get IPv4 address from a router. Okay. So we know host is there. For each host, we'll be having MAC address, right? Okay. Yeah. So getting the IP address from its router is called reverse ARP. Okay. So by default, host will be having MAC address will be there. Okay. So getting the IP address of a host from the router is called reverse ARP.
Okay.
Okay. And we have one more type of ARP that is called proxy ARP. Okay. So proxy ARP, if you remember, while transferring the while going the traffic between the networks, we have the router, right? So it needs to get some information, source IP, destination IP, source MAC, and destination MAC. Okay. So here, like if destination is some other network, we can't get this MAC address, right? So at the point of time, router is providing its MAC address. Once router is reaching, it is removing and it's forwarding the traffic, right?
Yeah.
So in this process, what's happening? Router is providing its MAC address. Okay. That is called a proxy ARP. So proxy ARP is a method through which a layer 3 device may respond to the ARP request for the target which is in the different network from the sender. Okay. Suppose sender is in one network, receiver is in some other network. Okay. While sending the information, it needs to have a source IP, destination IP, source MAC, and destination MAC. Okay. So here we don't know about destination MAC. So that's why what's happening? This router is providing its MAC address instead of the other destination server, destination MAC address, right? That's what the layer 3 device means. It's a router. Okay. So router is responding to the ARP request for the target in a different network from the sender. Okay. Is it clear? From source is one network, destination is one network. If you want to send, we need destination MAC address. ideally we won't get the destination MAC address if router is in place. Okay, so at the point of time, router will provide response to ARP request. So like getting the IP address is called, getting the MAC address is called ARP, right? Okay,
Yeah.
getting the MAC address is called ARP. Okay, so here I know what I can say in a simple way. Getting the ARP, MAC address from host is called ARP. Okay, getting the MAC address from layer 3 device is called proxy ARP.
Okay.
That is about proxy ARP. Okay, and we have one more ARP called gracious ARP. Like gracious ARP also is nothing but like it's to identify the duplicate IP address in the network. Gracious ARP will help us. So gracious ARP is an ARP request of the host that helps to identify the duplicate IP address in the host and the network, we can say, in network.
Oh.
Okay, so we have different types of ARPs available. One is like ARP, inverse ARP, reverse ARP, proxy ARP, and gracious ARP. Okay, so ARP is nothing but it from IP address to MAC address. Inverse ARP is nothing but MAC address to IP address. Okay, so let's write here. Okay, ARP, IP to MAC. Okay, inverse ARP, MAC address to IP address. Reverse ARP is nothing but getting IP address from router is called inverse ARP, reverse ARP. Okay, and we have proxy ARP. IP to L3 device MAC address is called proxy ARP. We can't tell like IP to layer 3 device. So we can say like it's a method in which router is responding to ARP request when the destination different network. Okay.
Okay.
We have the router, two different networks are there. So we won't get the destination MAC address directly when you're trying to access from the other network. So at the point of time when we send ARP request, so this router will respond to the ARP request. That is called proxy ARP. Okay. And the gracious ARP is nothing but like it helps to find out the duplication of IP address in the network. This is about ARP and its types. And like the last one is packet traversal in a network. Okay, so we discussed, suppose A, B is there. Okay, so when we are sending information from A to B, okay, so what all information we need to have? Source IP, destination IP, source port, and destination MAC address. Sorry, destination MAC address in general. Leave about port information. Yeah. Okay, so while we are sending information from A, it will send to switch. Okay, switch, router. Okay, so here what's happening when the traffic is going out of the switch, in switch it will send a broadcast message for the first time. Okay, but the destination IP is not available here now. Destination IP is 192.168.1.2. So here we have 0.2 only, so it is not available. Okay, so it will forward the request to router also. Okay, so in the router it will check the routing table. So for this subnet, so for this it will check 192.168.1.0. Okay, we are pointing to 10.0.0.2. Okay, so it will check the route. So we have the route available. Okay, then what it will do? It will send to this ARP request. It will send a response saying that take my MAC address. Okay, it will provide router MAC address. So we have all the 4 information. Then the traffic will go here. Okay, once it is reaching the router, again it will remove its MAC address and it will forward it to this router too. Okay, so from the router to what it will do? It will forward the traffic to switch. Okay, in the switch we are having the information, right, about it will send a broadcast message first time. Okay, so IP address is there, destination IP we have, but we are not having the MAC address when it is leaving out from the router. Okay, so it will respond to this ARP request and it will save in the MAC address table, ARP table. Okay, and the second time also if it is coming, It's the same thing. It will reach the router, and from here R2, and from switch, we are having the ARP table information, and then directly it will send to this router, this computer. Okay. Similarly, it goes. Suppose we have computer C here. Okay. So when you are trying to access computer C from network A, again, it will send. It will send to switch. We are not having like the IP address information which is connected to the switch. Then it will sound to router one. Router one, what we have route in place, right? We should be having route in place. Okay. So for 2.3.0 network, right? 3.0 network, the next hop IP address is this only again. Okay.
Yeah.
So it will send here. And once the traffic is reaching here, again it will check if its network is directly connected or what. It's not connected. Then what it will do? It will check the routing
Again,
table.
it will.
So routing table we would be having here. We should configure this. Okay. 192.168.3.0 pointing to 10.0.1.2. Okay, it is pointing here, router 3. So once it is reached router 3, it will remove this MAC address. Once here it is reaching here. Okay. Once it is reached, again it will send to this switch. For the first time, broadcast. Once if you have this ARP table, then it will send directly to this computer. This is how the packet traversal in the network.
Okay.
Is it clear?
Yeah. Yes.
Okay. Yeah, in this session we discussed about like many topics. Let's go through one by one. Okay, so we discussed about what is broadcast domain, what is collision domain. Okay, so when it comes to hub we having like one broadcast domain and one collision domain. But in case of switch, one broadcast domain, and the collision domains, it depends on the number of ports it consists of. Okay. And we discussed about what is unicast, multicast, and broadcast. Unicast is one-to-one communication. Multicast is nothing but one to many, but not to everyone. And broadcast is nothing but one to all. Okay, that is about unicast, multicast, and broadcast traffic. And we discussed about what is simplex, half duplex, and full duplex. Suppose we have two devices, that is A and B. Simplex is nothing but only unidirectional communication, that is only from A to B only. So here A is a sender, B is a receiver at any point of time when it comes to simplex communication. When it comes to half duplex, if you have two devices A and B, both A and B can send and receive the information, but only one at a time. Okay, suppose A is sending the information, B should be receiving that. If B is sending the information, A should be receiving that, but only one at a time. Okay. So full duplex, both can send the traffic, but it's a bidirectional traffic, and simultaneously they can send. There is no restrictions here. Okay, that is about simplex, half duplex, and full duplex communication. Then we discussed about VLAN. VLAN stands for virtual LAN network. So what we are doing here, we are creating the logical network from multiple physical networks. Okay, and so this is an example, we discussed about that, and we have VLAN ranges, and we discussed about port channel communication also. If you want to share, the bandwidth between the switches, we'll go with the port channel communication. So if you go with port channel, not only sharing the benefits, it will be act as a backup link also if one failure. Okay, and we discussed about ARP and different types of ARP. Okay, so we have ARP, IP to MAC address. Inverse ARP is nothing but MAC address to IP address. Reverse ARP, getting the IP address from the router is called reverse ARP. So in case of DHCP, we'll get DHCP, dynamic host controlling protocol, we discussed, right? So what host is doing? Host is getting IP address from the router. Suppose you connected to your Wi-Fi network. Okay, so when you are trying to as soon as you connected, you will getting IP address, right? So that process is called reverse ARP. Okay. So proxy ARP is nothing but layer 3 device is responding to the ARP request when the destination subnetting different network from the source. Okay. That is about proxy ARP. And we have one more ARP called gracious ARP. Gracious ARP, it helps to identify the duplicate addresses. And lastly, we discussed about the packet traversal in a network, how it is transferring, from one network. Suppose, if a source and destination in the same network, okay, then it won't go to router also. It will come to switch and
switch on.
It will point out here. Okay, by using. Is it clear?
Yeah.
Yeah. So by this, we end up with most of the network basics what we need to be aware of as a security engineer. Most of the things we have been
Okay.
discussed, and in like from going forward, we'll discuss about the next session related to security.
Okay.